Now that we've seen the basic properties of the basic logarithmic functions, let's go ahead and take a look at how we can figure out some properties of more complicated ones. So let's find the domain, the range, the x and y-intercepts for these two functions. Now both of these are transformations of the function log base 2 of x, but we won't be graphing in this example. We'll be using some algebraic ideas to figure out domain, range, x and y-intercepts for these transformations. Now as for part A, for the domain, we discussed earlier that we can only take logarithms of numbers which are bigger than 0. So we'll set what we're taking the logarithm of, which in this case is 1 minus 2x, to be larger than 0. And on solving for x by subtracting 1 and then dividing by -2, remember flip the inequality sign when you divide or multiply by a negative, we get that x is less than 1/2. So the domain is the x values that are less than 1/2 and an interval notation that would read -∞, 1/2. Now as for the range, if you apply any transformations, any of the transformations that we have talked about in this class to a logarithmic function, the range will remain unchanged. The range will be -∞ to infinity. So in this case, and in the case of any transformations applied to logarithmic functions, we get a range of all real numbers. Now to find the x and y-intercepts, we'll set y and x equal to 0 respectively and solve. Remember, if you have a function and you want to know its x-intercepts, that's where the function crosses the x-axis, then at these x-intercepts, y is equal to 0. I say this because sometimes it is confused what I need to, or what a student needs to set equal to 0 to find a particular intercept. And this here, visualizing the picture, may help you remember that y has to be 0 at the x-intercepts. So to find the x-intercepts, I will set y equal to 0. So we're going to set y, which is, of course, h of x equal to 0, and we'll go ahead and solve. So log base 2 of 1 minus 2x equals 0. We can apply the definition of the logarithm, or in other words, we can convert to exponential form, and we get 1 minus 2x equals 2 to the 0. Remember, if you're taking the logarithm of something and it's equal to some other number, then we move the base over to the other side and we keep on the left-hand side whatever we were taking the logarithm of. The 0 moves to the exponent, and so we arrive at 1 minus 2x equals 2 to the 0. Now 2 to the 0 is 1, so 1 minus 2x is going to be equal to 1, and I can now solve for x. I think I'll add 2x to both sides and subtract 1 from both sides. Subtracting 1 will remove the 1 from the right-hand side. Adding 2x will remove the 2x from the left-hand side. And on the left-hand side, I'm left with 0 because 1 minus 1 is 0. And on the right-hand side, I have 2x, and thus x is just equal to 0. So x equals 0 is the x-intercept. How about the y-intercept? Well, at the y-intercept, x is equal to 0. And so I'll set x equal to 0, and that will give me my y-intercept. So 2 times 0 is 0, so this is just log base 2 of 1, which is equal to 0. So y equals 0 is the y-intercept. Let's take a look at this second problem where we had negative 2 log base 2x plus 1. I went ahead and recopied this on a new piece of paper here, and to find the domain we'll set whatever we're taking the log of bigger than 0, and that turns out to be relatively easy to do. We just have that x is greater than 0, so the domain is 0, infinity. The range, since this is a transformation of a logarithmic function, is just going to be all real numbers. Now let's take a look at the x-intercept. So remember, to find the x-intercept, we'll set y equal to 0, and we'll solve. So negative 2 log base 2 of x plus 1 equals 0. I'm going to subtract 1 and divide by negative 2, so then I would get negative 2 log base 2 of x equals negative 1. And then dividing by negative 2, I get log base 2 of x equals 1/2. Finally, I can convert to exponential form, and I get that x is equal to, we'll move the base over to the right, 2, and what's on the right becomes the exponent to the 1/2 power. And doing something to the 1/2 power is the same as taking the square root. So the x-intercept would be the square root of 2. Now I think I can fit my y-intercept on here as well. So let's go ahead, we'll divide this, and let's find the y-intercept. And remember, to find the y-intercept, we set x equal to 0. So negative 2 log base 2 of 0 plus 1. However, 0 is not in the domain of the logarithm. So this quantity that I've written, negative 2 log base 2 of 0 plus 1, is not defined. And if you come across this situation, we simply say that the y-intercept does not exist, or equivalently, there is no y-intercept. And again, that's since log base 2 of 0 is not defined. We'll see why this is true, the fact that there's no y-intercept, in a moment when we graph these two functions.